Hi, welcome back. On today's lecture series, we are going to discuss about the power flow solution using Gauss-Seidel method. So here we have to do an empathy. What is a power flow solution? So here it will be a very complex and it goes to the n number of iterative methods by using the mathematical analysis and the convergence. It can be understanding and when we have to use which method. So when we have to use Gauss-Seidel and when we have to use the Newton-Raphson method and how many iteration has to be followed and when we have to get the actual result and whether we have to do the manual calculation and how much amount of time which is required to compute the answer. So it has the n number of challenges while thinking about the power flow solution using Gauss-Seidel method. In the real world context, the power engineers they need a quick solution as much as possible. And if you go for the large system, the computational is very high, so it takes more time. And the accuracy versus speed, it will be trade off. And the foundation for advanced method. So these are some of the issues we are facing. And while defining the empathy of the problem statement, so the main challenge, so here we have to solve the non-linear power flow solutions for n number of iterations for the unknown bus voltages. And the ultimate aim of our power flow solution method, which is used to determine the voltage magnitude and as well as the phase angle of the voltage at each buses within the acceptable tolerance. So for these conditions, we have to take some of the few constraints like if it is load bus, the P real power and reactive power is known, and for a slack bus, the voltage and phase angle will be known, and for the PV bus and for the generator bus, real power and voltage will be known. So here we have to construct the Y bus, and here we have to take any one slack bus, any one generator bus as the reference bus. Okay, so how do we systematically update the voltage which is estimate until the convergence which is meet out? So at this ideate stage, so these are the algorithm which we are following in the Gauss Seidel. So at the step number one, we have to initialize. So here we have to read how many buses are there, which are all the how many buses are there, how many generator bus, how many load bus, and what is a slack bus. So what is the known value of each buses like voltage, real power, reactive power, phase angle, etc. So except for slack bus. So we have to read all the data. So after that, we have to form the bus admittance matrix. Once the bus admittance matrix is done, at the initial condition, we have to assume all the bus voltages as 1 per unit except slack bus. So, okay, so this is the main first step. At this first step, we have to assume the reference voltage. We have to assume the initial voltage for all bus except slack bus, which is 1 per unit. And step number two, we have to compute the current. So we have to calculate the current. So with respect to the real power and reactive power and based on the voltage for each buses. So in third step, we have to update the voltage level for the next iteration method. So it may go for nth iteration, the first iteration, third iteration, like say right. So in every iteration, we have to update the voltage rating. And in the fourth step, once the voltage is determined or the current is determined, so we have to check the convergence, whether the determined value which is within a permissible level or not. So based on that, we have to do the next step. So this is the mathematical foundation in order to determine the bus voltage with respect to the nth iterations. So which is equal to YII. So YII is nothing but which is used for which buses like that. So that is PI minus JQI divided by VIK. We whole power this VI power star. It indicates the complex conjugate minus summation J is equal to 1. I is equal to 1. So up to n. So here the formula Yij Vj whole power k plus 1. So by using this formula, we can able to determine the bus voltages for all the buses for the unknown value. So these are the acceleration factor. So here we have to update the standard one. So here for slow convergence for large system and fast convergence using, that is nothing but the convergence. It may be called as the acceleration. The acceleration is called as an alpha. It may be 1.4, 1.5 up to 1.6 will be there. So we can able to substitute the alpha value as acceleration factor. It can be multiplied with the actual bus voltage. So that is called the actual the accelerated bus voltage in the particular buses. So this is a flow chart we have to construct by using the flow prototype in the flow prototype. So we have to read the system, like how many buses are there, what is the bus admittance matrix, what is the real power, reactive power, and some of the values which is known. And we have to set the initial voltage except the slack bus, and for each bus we have to compute the new unknown voltage or magnitude or real power or reactive power, whatever it may be, and we have to apply the acceleration factor when it is needed. Then we have to check the convergence, and in this last step, so the output voltage, line voltage, losses, everything can be calculated. So this is the testing in the convergence analysis. So here the block dot it indicate the iterative method, where the first iteration, second iteration, third iteration, etc. And the low color it represent the bus 3, and here it represent the bus 2 voltage. Here all will be marked in the per unit value. If you go for n value, so it will be slightly increases. So these are the few real-time applications which can be used for the grid operation, like the supervisory SCADA and data acquisition system, and for the renewable integration like solar, wind, which is can be synchronized with the power grid, and it may be required in the future expansion, and for the system planning, whether for short-term or long-term planning. So this is a topic summary by using the mind map. So here we have to read out all the input data, like admittance matrix, PQ value, slack bus or generator bus, and what is the tolerance level. So based on that, we have to develop the algorithm. So here we have to go for the iterative voltage update to determine with respect to the acceleration factor. And in the stage step, we have to check the convergence, whether it's within a limit or not. So based on that, we can get the output, like the bus voltage, line flow, system losses, etc. So this is a curative challenge. Why does Gauss-Seidel convergence faster than Gauss method for power flow analysis? If you know the answer, just to put in the comment section. And this is another assessment, a 3-bus system. So the data will be there. So here, by using the Gauss-Seidel method, so we have to determine the bus 2 voltage with respect to the first iterations. So these are the few textbook and reference books for this topic. Thank you.